All right, so the second part of this, and so I title it this way, is this still 7-4, but we're going to call it day 2. All right. Now, the idea behind these is we've already said that basically what was going to happen is they're going to be quadratics, but really the added thing on this is we're going to have to check the solutions. Okay, so we're going to have some of the solutions that are going to be, we've done this before, what they're called extraneous. Okay, so day 2, we'll look at extraneous solutions. Okay, now, so a lot of times what's going to happen is the directions are going to tell you that you're supposed to check for extraneous solutions, and they do that in algebra too. But later on, when you get it, especially into trigonometry, they don't always tell you to do that. And so the idea is you're supposed to check for extraneous solutions anytime you do this. Let me write it down for you. Okay, anytime that you raise both sides of an equation to an even power, you're supposed to check for extraneous solutions. Okay, so anytime that I raise both sides of an equation to an even power, so if I was like going to square both sides or raise both sides to the 4th power, then I have to go back and check to make sure that that solution's really a solution. Remember what an extraneous solution is? Well, it's not necessarily imaginary, but it's just one where you get it out by working it correctly, but yet when you plug it back in, it doesn't work. Now, let me kind of show you the basis of this, okay? Let's say that we had this problem here, that we had the square root of x was equal to -4, okay? Now, so how would we solve that? Square both sides, okay? And so that will give me x equals what there? 16. Now, is the square root of 16 really -4? No. Now, we solved it correctly, right? We did the proper steps, but yet it doesn't work out. And so the extraneous solutions, the way that we're going to check for them is this. If I take the square root of something, this value over here has to be positive. I don't think I spelled that right. Positive, all right? Positive, all right? All right, and that's what we're going to check for. And so a lot of times what people do is they take their solutions and they go all the way back to the original problem and they try to plug them in, and you can do it that way. But the easy way to check it is to make sure that the result that you get from whatever you take the square root of, make sure that result is positive. Okay? Now, let's look at an example. All right, or hang on, let's do this first. We need to review something real quick. All right, so quick review before we actually start into a new little equation. Let's look at these problems and let's go back and remember how to expand this, because this is something that we'll have to be doing in these equations here in just a second. All right, so you remember this doesn't really mean right here what x squared plus 25 does it. Okay, it means what x plus 5 times x plus 5, and then we'd FOIL it out. All right, but you remember our shortcut? All right, so the shortcut is what we square, and then we do twice the product. Okay, so square, okay, and right, twice the product would be 10x. Is what? 5 times x is 5x, and 5x double would be 10x. So this is opposed to doing it like this, where you say x plus 5 times x plus 5 and FOIL it, because that takes about 3 steps there, and I can just do it all in one. Now, let's see if you guys can tell me the next one there. So what's this one going to give us? All right, and let's do the end. Plus 9. Now do twice the product in the middle. That would be right, minus 12x. Let's think about it. All right, what's the product there? 2x times negative 3 would be negative 6x, and twice that would be negative 12x. Okay. All right, now let's try this one. So I always do this. I do the ends first and then kind of fill in the middle. All right, so let's do the ends first here. 25x squared. All right. All right, in the middle. Okay, let's see. 5x times negative 2 would be negative 10x, and then double would be negative 20x. Okay. Now, you're going to see this in a minute where we're going to actually use this shortcut in solving our equations. All right, now let's look at one of these radical equations where we're going to have to check it. All right, now this is actually here example 4. All right, you don't really have to look at it. It's on page 387 if you want to look at it though. All right, it's got square root of x minus 3 plus 5 equals x. Now, it's still a radical equation, so that's not any different than yesterday. So we're still following the same steps, except for now, what the directions are going to tell me is I have to check this one for extraneous solutions. Okay, so we're still going to isolate the radical and then undo the radical and solve it. Now, the solving part is going to be a little different today. Now, so help me isolate. What do we need to do here? All right, right. So we get square root of x minus 3 equals x minus 5. Okay, now it's isolated, right? Now, right, undo it. So we'll square both sides. Okay, so I'm going to do this. I'm going to square the left side. Y'all square the right side. All right, so, all right, I'm done. Okay, what's the right side? All right, x squared 10x plus 25. Okay. All right, so you remember what I told you, always take the easy one, you do the hard one. Now, so what are we looking at now? A quadratic, all right. Uh-oh, I touched the screen. Here we go. Oh, I don't want that either. Oh, sure, that's pretty interesting there. All right, now, right, it's a quadratic, okay? So you don't just isolate x, do we? What if it's a quadratic equation? We have a handful of methods to solve them. All right, well, how can we solve them? All right, factor, quadratic formula, right, complete square. All right, now that's the bottom line is we have to set it equal to 0. Okay, so let's subtract x here and add 3 here. Right, we got to set it equal to 0, right? So this side we want it to be 0. And so on the right side here, we'll get x squared minus 11x plus 28. All right, now, so let me just let you in on like a big hint here. On the problems that they give you, they all factor, okay? There's actually, I think there's one problem in the exercises that don't, I think, and I didn't even probably assign that one. Yes, okay? So they'll be nice. They'll actually factor out for you. So help me factor. What are factors of 28 that add to, yeah, 4 and 7. Okay. So 4 and 7. Both of them's minus. Okay, so we'll get x to be 4 and 7. Okay, now, so it was a quadratic, and that's definitely different, but we have to check this one for extraneous solutions. Okay, we did square both sides, so we'll do that. Now the directions will tell you. Now, so what some people do is they go back to the very beginning there and they plug in 4 and 7 and make sure that it's true. All right, well, I've got a quicker way of doing that. Instead, what I'm going to do is go back to the isolate step, which would be this one right here, right? Now, y'all think about this, okay? If I take the square root of something, what has to be true about this result? Right. This right here has to be positive, right? And as long as that's true, then that's okay. Now, now the squares weren't there originally, were they? We did those, so I'm not looking at those anymore. Now, how do we know if x minus 5 is positive? Well, that depends on what x is, right? So x was 4 and x was 7. So if x was 4 right there, what would happen? It would be negative, okay? And so that can't be negative, can it? Because the square root of something has to be positive. So we say that x equals 4 is extraneous. So we got to cross him out, okay? He goes to number jail. That's where extraneous solutions go, okay? All right, because that's what x is, right? All right, well, we're going to check it too. All right, so go back. You remember what we said here. If I take the square root of something, the result has to be positive, right? So this x minus 5 needs to be a positive value. If I put in 4, it would not be positive, would it? Okay. Now, what if I put in 7? And that would be okay. 7 minus 5 would be 2. Okay. And so the x equals 7 one, that's my one answer. Okay. Yes. Don't worry about them. Okay. Don't worry about it. All right. Yeah. Let's do, we'll do one real similar here. All right. Yeah, let me do this. Let me make it bigger here. All right. Let's look at this one. Let's do 5x minus 1 to the 1/2 power plus 3 equals x. Okay. Now, this one, I didn't give it as a radical there. All right. But isn't 5x minus 1 into the 1/2 power, doesn't that really mean square root? Okay. Now, if you want to write it that way, you could. Now, you want to rewrite it so it's the square root instead? Okay, that's fine. All right. That would work. All right. Now, let's isolate the radical. So what do we need to do there? All right. Subtract 3. Okay. Square. All right. All right, let me see. Let me go to the ends first. What? X squared, and then 9. All right, the middle term you said was negative 6x. That's right. Okay, so now, what are we looking at here? Quadratic. Okay, so we need to set it equal to 0, and it's probably going to factor. Okay, so if we're going to set it equal to 0, we're going to have to get rid of that and that. All right, so let's take it over. So x squared minus 11x plus 10. And if you notice, that factors. Okay, factors of 10, then add to give me 11. All right, 10 and 1. All right, they're going to be the same. They're both going to be negative. All right, so it gives me 10 and 1. All right, now let's check to see if they're extraneous. All right, now let's go back to the step where we isolated. All right, that would be right there, right? Okay, now, so again, when I take the square root of something, the result over here has to be positive. Now remember, the squares weren't there initially. I did that. Okay, so the x minus 3 over there has to be positive. So if x was 10, it would be positive. Okay. All right. If x was 1, that'd be negative. So 1 is extraneous. 10 is okay. All right. Now, there are cases here where actually both solutions could work. You can have two solutions. You could have that neither solutions work. In that case, there would be no solutions. Okay. If neither of them worked, no solutions. All right. Yeah, you have two of them. Be two solutions. You can have that happen. Now, most of the time, what happens is one works and one doesn't. Okay, the majority of the time, but not always. All right, let's look at one more, and then I'm gonna let you guys start on this. All right, let's look at this one. Um, yeah, come on. I have to narrate though. So, you want to? There you go. All right, so y'all help her out. Mm-hmm. All right. Yeah. All right. There you go. Square. Not really. 12x. That's right. Plus 9. All right. So set it to 0. There you go. All right, now, y'all, what's different from this one, from those first two that I did? All right, it's got a leading coefficient, so you're going to have to split and group to factor it. So we're looking for factors of 28 that add to be 11, right? 4 and 11. Both of them would be positive. All right, the 12x, just keep working. All right, remember the middle term, we do twice the product. So 2x times 3 is 6x, and doubled is 12x, all right? All right, so you got them split there, so you can factor out x. There you go. Yeah, 1. There you go. Yeah, negative 7 over 4. Okay, and then negative 1. Okay, that'll work. I'm gonna check them for you. All right, so you can probably bet here one of them's not gonna be good. All right, see if you can kind of maybe tell. All right, go back to where here, no, here, the isolate step right there. Okay, so now this value right here needs to be positive. Okay, so put in negative 7/4. And the thing is, we don't really need to know exactly what it is. All we need to know is it positive or negative? So I mean, push it in your calculator, punch in 2 times negative 7/4, which would be like negative 1.75 plus 3. All right, is it positive? No, what is it? Negative. All right, so negative 1/2 or negative 0.5. So that one, negative 7/4, don't work. Okay, now what about -1? 2 times -1 would be -2, and -2 plus 3 would be 1. So that's okay, because remember, this value right here, this 2x plus 3, because I'm taking the square root of it, has to be positive. So that's my only valid solution there. Okay, now y'all look at the homework. Try the first two. Usually the first two have been the hardest in this.